Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about linear regression and how the line of best fit works. Okay, so linear regression describes how a response variable, y, changes as an explanatory variable, x, changes. And we use this to predict the values of y for a given value of x. All right. The most accurate regression line is the least squares regression line. It minimizes the errors squared of y, so the squared error. It always passes through x bar, y bar. Remember, x bar is the mean of your x values and y bar is the mean of your y values. So it's always going to pass through that point, even if that's not a point in your data set. Your line's always going to be through that point. It is not resistant to outliers, so outliers are going to have a great impact on your line of best fit. So to get this on the calculator, you would go to Stat Calc 8, which is the Linreg A plus BX. So we use that one for statistics. It's a little different than the AX plus B that you've used in your other algebra classes, maybe. And then we will replace x and y units with their names. So when we're writing the equation, you'd actually put the units in there. So that's very important. And then the equation is this y hat equals b sub o plus b sub 1x. All right, so this is y hat. And that gives you the predicted y values. So you want to have that hat on the y to let everybody know that these are your predictions. B sub o is your y-intercept. B sub 1 is your slope. Okay, then sometimes they won't give you all the data to put into your list, but they'll give you other pieces of information about the data. And so you might need to use these other formulas to find the slope or the y-intercept. So to find the slope, it's r, which is your correlation coefficient, times the standard deviation of y divided by the standard deviation of x. And to find the y-intercept, it's the mean of y minus the slope times the mean of x. All right, residuals, which are your errors. All right, so let's say here's our scatter plot, and there's my line of best fit, my least squares regression line. So the distance from one of your actual points to that line of best fit is the residual, okay? That's how off our line of best fit was at that point. So the actual dot, the little black dot, was our actual y value. And where it meets up, where it lines up on the pink line, is our predicted y value. So to calculate residuals, we do the actual y minus your predicted y. And then the sum of positive errors equals the sum of negative errors. So here's a -1. The ones that are above the line of best fit would be your positive errors. The ones that are below will be your negative errors. And if you added all of the residuals, the positive residuals and the negative residuals, they would end up equaling. Okay. The sum of all your residuals should be 0. Okay, so they should balance each other out. And the mean of the residuals should be 0. All right, extrapolation is using an x value that is far outside the range of data given to predict a y value. Okay, so you don't want to make assumptions too far into the future. All right, if you only have data that goes from 1960 to 1970, you don't want to make predictions about 2025. Okay, that's too far away from the data we have. A lot of things could change. So extrapolation is not trustworthy, and it might not continue to follow that same type of linear relationship. That trend might change. All right, the coefficient of determination is r squared. And then we have like a sentence. So whenever you're asked to interpret the coefficient of determination or asked to interpret r squared, you want to say something along these lines. So r squared, whatever that value is, as a percentage of the variation in the y variable, and you would put that in context, can be explained by the variation in the x variable. And again, you'd put your variables in context with units if possible. Interpreting slope. So the symbol for slope is b sub 1. And so if you're asked to interpret slope, you would say something along these lines. For every increase of 1, whatever your x variable is with units, the y variable increases or decreases, depending on if it's a positive or negative slope, by whatever your slope units are on average. So you want to make sure you're saying on average. Remember, slope is the average rate of change. Okay? And in AP Stats, you want to make sure that you're not saying too much things are definitive facts. On average, it appears approximately. Okay? Residual plots. So a scatter plot of the x variable versus the residuals. It helps us assess the fit of the least squares regression line. So is this a good line of best fit? So in order to do this, you have to run a regression, a linear regression, on your calculator first. So you got to do with your normal data, stat, calc 8, do your linear regression. When you do that, your calculator automatically makes a new list called residuals. And then you would go into your calculator and do another one with your x variable, and you would change the y variable to residual list that your calculator created, and then you would get your residual plot. If you see no pattern and everything's really scattered, then our line is a good model for the data we're given. If you see some sort of pattern or curve, then another model or equation would be a better fit for this data. So maybe it's quadratic, maybe it's exponential. Okay, so maybe it's something else. So if this is scattered, all the points are just kind of all over the place, that is good. That's what you want to see. Okay, so then we can check that off and say, our line of best fit should be a good model. Bad residual plots come from a pattern or curve. So you might see a curve like this. You might see it kind of fanning out. We call that a fan or a horn pattern. And then that last one was also curved. All right, putting it all together. So we have some flights to different destinations. They gave us the total distance and the cost of airfare. So I'm going to go ahead and I'm going to put all this data into my calculator. So I'm going to put distances, all the distances into list 1. Airfare, all the airfare cost into list 2. Now, if I went ahead and put that into list 1 and list 2 and I made a scatter plot, it looks something like this. I'm going to label some of the points. Okay, I need to have some sort of labels on my x and y axis. I just went to 2 points and put their values on there. And then I have airfare as my y variable and distance as my x variable. So explanatory and response. And then I have a title, airfare versus distance. And then if I go to stat calc 8 and do the linear regression, there's an option where I can have it draw the line of best fit for me. So I can have it store the equation in one of my y1. So you'd have to go to vars, y vars, and then select y1, and it'll graph it for you when you go to zoom 9 after that. So there's my line of best fit. So the equation, when you do it on your calculator, when you do the stat calc 8, that linear regression, it gives you the the numbers that match up with A and B in the calculator notation. So it gives you your slope and your y-intercept, and then you're going to just plug it in to that equation, but you're going to put all the variables context. So y hat would be airfare hat, so the predicted airfare is equal to 83.27, that was my y-intercept, plus 0.117, that was my slope, times the distance. The calculator also should be giving you r and r squared. Well, r was 0.75. Remember, that's your correlation coefficient. And r squared was 0.632. That's your coefficient of determination. Okay, if your calculator is not giving you those values, then you have to turn your diagnostic on. Okay, and you can just go to catalog and search for diagnostic and then turn it on. And then the residual plot. So I'm going to go back into my stat plots and I'm going to change my y variable to be my list, which is the residual. Okay, so you're going to go to list and then search. It should be at the bottom for resid, and that's your residual list. Put that in for your y variable, and then your residual should look something like this. Remember, we want to see just a scattered mess of points. All right, this looks fairly scattered. I'm going to put some values here. So my linear model, my least squares regression equation is a good model. I'm going to go ahead and interpret r squared and interpret the slope. So r squared is my coefficient of determination. And I would say 63.2% of the variation in airfare in dollars can be explained by the variation in distance flown in miles. And then interpreting the slope, for every increase of 1 mile, the airfare increases by 12 cents on average. All right, that's it.